All right. Thank you,
you.
Rune, first of all. Thanks to the great organizing team today. We are right on time to start. And today we want to talk about supercharging your app with Firebase and Stream. All right, so I can already start. Like Jeroen mentioned, like this is we are sponsors, right? Stream and Firebase decided to sponsor this conference because we wanted to support this, and now we had the chance to just say, yeah, let's give this marketing talk and talk about, yeah, you should use our products. They're great, right?
Absolutely.
That's always fun to listen to, right? But we decided, nope, we won't do this. We decided we want to do something else. But first of all, a quick introduction. I'm Stefan. You mentioned this. I'm a developer advocate for Stream.
And I'm Peter. I'm a developer advocate on Firebase based in Hamburg.
So we don't only work as developer advocates, but more importantly, we're also human, and a special kind of human. We are developers, right? And what do developers do? They do side projects, right? So we decided, hey, we have a great idea. We want to do our own side project. And I could talk about this a lot, but I actually want to show you because we've built something. And we want to continue building this together with you today because like what could go wrong live coding on a stage, right? So this is the app, like it's running in the simulator here. We decided we all love Apple products, right? And we always buy the newest ones because, yeah, we're like that. But we want to get rid of our old ones as well, right? We want to give them a second life, so we want to build a platform for people to get rid of their old Apple stuff, to allow themselves to buy the new things when they come out. So we have this app here, right? It's just a list. You can have all the products here, like whatever you like. It's Apple Watches, Macs, and whatever. And what we can do, we can navigate to a detail page here. We see the product is there. We see the seller here, which is called Apple Lover 90 and has a very reassuring picture.
Yeah, he's verified, right?
He's verified, right? So like
paid $8, I guess. Trustworthy.
It seems legit, yeah. So like no problem with that, right? Okay, so that looks good. Like this is what we've built so far. But of course, that's not all. We have built this. We will continue to build this. But first, I want to give it to Peter to talk a little bit about the tech stack that we've been using.
So you probably guessed it, the application itself is built using Swift and Swift UI, and you might have seen some of those sweet and very subtle animations that Stefan built. If you want to know more about that, I think he's got to talk about that, probably on YouTube somewhere. The backend of the application uses Firebase because. And we use a couple of Firebase's products. So you might know that Firebase is more than just a database. We've got 18 plus products in there, and here are just 3 of them that we're using. So probably the most important one is Cloud Firestore, which is a NoSQL cloud database, document-based database that's horizontally scalable, and we use it to store the data about our products in there. We also want to use cloud storage to store all the images and maybe any other big chunks of data that we need in a blob storage. And we use authentication so that users can sign in and that we know who they are and we can connect their recent purchases and to make it easier for them to chat with the people who want to sell things. So we thought about adding 2 new features to our application. And the first one of those is we want to allow people to chat with the sellers. So if I want to buy a new MacBook or a used MacBook, I want to chat with the seller and understand which condition it actually is in. So that's the first feature here on the left side. And then after I've conversed with the seller and they've actually sent it to me, I want to get a receipt by email so that I've got something for tax purposes, for example. And that's the other feature on the right-hand side. So I want to be able to receive an email with the receipt. So there is a challenge. We're basically very small, just 2 lonesome developers. We don't have a large engineering team. We don't have much time. We want to launch this quickly, and we don't want to run our own servers. We only know Swift well enough. We don't know any Python, Go, Rust, JavaScript, TypeScript, whatsoever, or we just want to do it in Swift, right? So these are all the challenges that we're facing. So how can we overcome those? And yeah, maybe Stefan can talk a little bit about how we can update our tech stack.
Well, as you can see, the tech stack we have right now is there. That's working nicely. So we would love to add some chat functionality to that. I mean, you know, there's like, I have an idea for that. So I think we could probably use Stream for that. And yeah, that could work really nicely, right? We can get UI for that. We can get the backend for that. That looks good. But let's look at that. What does that mean? Like adding Stream to this, right? So Stream consists of a few things. So you get UI components out of the box, both for UIKit and Swift UI. So that's nice. We don't have to do much there. We get an infrastructure. So like Stream is managing that, so managed services. We don't have to deal with those pesky servers that Peter mentioned, like we want none of that. So that's good as well. And then there's authentication, right? Because Stream requires us to create a token to verify that people who are trying to use the service are actually legit, right? So we need to do some form of authentication there and some token generation. And this follows the BYOS term, which we invented, and is called Bring Your Own Server. So we're good. Like UI components, that's fine. We're good for infrastructure. We don't have to do much there. We just use the service. But authentication-wise, well, it requires us to build our own server, right? And as Peter mentioned, like we're just 2 lonely developers. We don't have a large team. So yeah, like what could we possibly do here? Do you have any idea? Peter, maybe.
Yeah, so I saw Tim in the audience. So Tim, can you wave? Hey, Tim. There he is.
Big fan.
So one option might, of course, be, you know, given that we want to use Swift to resolve our miracle over there, to use Vapor. I hear a lot of good things about it. And if you want to learn more about Vapor, talk to Tim. It's basically run Swift on the server, and I think it would be a great idea to use this. And Tim even wrote an article about using Stream in a Vapor server. So that would be a good idea. But I'm here from Firebase, so I need to, you know, take a stand and say, no, sir, we don't want to run and operate our own servers. We want to have it easy. So let's solve it a different way. Let's use Firebase. And one way to do that is to use Cloud Functions. So who here has heard about the term Cloud Functions before? Okay, quite a few. So for those of you who haven't heard about it, Cloud Functions for Firebase essentially is a serverless product which allows you to write code in JavaScript and TypeScript, and we'll come to that in a minute, and run it serverlessly, because you don't have to stand up the servers yourself. And Google will take care of scaling your code that runs in this environment automatically based on the demand. So if you, for example, if we have a Black Friday sale, or after Christmas people want to return the stuff they bought, it should be easy because Google will automatically add more capacity to our services. So that's really, really nice. There's a problem with JavaScript and TypeScript, though. We don't know any of that. So, we're very small. So what can we do? Well, there's a solution, and it's called Firebase Extensions. So extensions is a super overloaded term, and I'm really sorry about that. When you talk to an iOS developer about extensions, it can mean anything. So we're specifically talking about Firebase extensions here. So let me give you a quick introduction to what Firebase extensions are. Firebase extensions are essentially pre-built packages of functionality that you can easily add to your Firebase project on the backend. So things like resizing an image, transcoding a video, setting up or running a video call, integrating with services like Stripe, performing full-text search on Cloud Firestore and stuff like that, or sending emails. And the cool thing is you don't have to write any code because either Firebase or those other companies who provide those services have done the hard lifting for you, and you can easily add those features to your application and configure them. Under the hood, it's all Cloud Functions. And let's take a look now at how to implement this into our application. So what we want to do now is we'll switch from the slides to actual code and stuff to implement the chat functionality. And there are 3 steps that we need to take. First, I'm going to show you how to install the extension and configure it. Then we're going to implement token exchange, and Stefan is going to take care of that and connect the UI. So fingers crossed. And let me find the console. So here we are in our project. So this is Firebase, and I'm now going to go into the extensions module, and I want to add an extension. So let me first go and explore what's available, and we know that we want to do something for chat. So let me filter. So this is the extensions marketplace, and you can see that there are a lot of extensions that I can use. And we want to do something with stream, so we're going to pick this one, and I can see more details about this here. So it says, synchronize Firebase authentication users with stream and create and revoke stream chat authentication tokens. So exactly what we need. There is a little bit more explanation here, so if you're curious how it works, you can read that. But we want to install this now, so I'll click on the Install and Console button. Then I'm going to choose the project I want to install this into, and then I'm going to walk through this installation process, which tells me all about it. And here are the functions, the cloud functions that will be created in our backend project. So these are Firebase cloud functions that this extension will install. So now I need to enable a couple of Firebase and Google Cloud services for this to run. Most importantly, authentication and the secret manager, and then I can proceed to the next step. There is another review. I'm happy with that. I can choose where to run my cloud functions. We'll just leave the defaults, and then I need to provide the API keys. So let me find that in the stream console. We're over here, and then go to the app access. So we'll change those afterwards. No worries about that. So we'll paste it here, and then this one. I'm not even going to click on reveal. Okay. It's longer than that. So we're creating a secret. The secret is stored in Google Secret Manager, so it's kept safe. And then I can install the extension, and this might take a while. So it says a couple of minutes, and while we're waiting for the installation to go through, why don't we switch to Xcode?
Sounds good. So just to recap here, so we've done this, right? We've installed the Firebase extension now. And now we take 2 more steps, right? So we need to implement the token exchange in some form, right? Because we need to authenticate. And then we need to connect the UI. So let's jump into Xcode. I hope it's readable, but give me a quick thumbs up if it is. Yes, very good. All right, so we need to take a few steps here, right? And the first thing when using Stream, and I've already added the dependencies because, you know, dependencies can take a while to install, I've heard. So like I've added the dependencies already. So a place to initialize an SDK, a good place, is the app delegate. And how I know it's a good place is because, well, Firebase is using it. That's a good sign. But also, like in the good old days before the modern Swift UI lifecycle, the app delegate was heavily used to initialize things when the app starts. So let's initialize Stream. And we can do this by creating two objects. So first we have the stream chat object. Okay, that's pretty self-explanatory. That's the object that handles everything here. And then we are creating a chat client. And that's a bit of code, but all it does is it creates a config. We're adding the API key here, returning the chat client, right? So it's not a lot of setup. And what remains for us to do is now we can initialize stream chat by using the initializer and handing it the chat client. So yeah, that's it, right? Stream is initialized now. Very good. That looks nice. What we want to do now is, so we have this authentication mechanism, and I can quickly show this, right? So we have the products here. Users can log out, and then they can log in and sign up. And we have a nice code for that. So if I open up the authentication view model, then it's pretty like not too much code. We have two functions, one called login that calls the sign-in function from Firebase auth. That's fine. And we have the sign up function, which creates a new user. All right. And then we're adding a state change listener on initialization of this object. That means whenever the user changes, we get notified, which is good because we can handle login and logging out as well, right? So what we're doing, if there's a user present, we are setting this for later and are setting our authentication state to logged in. So pretty basic. If no user is there, that means we've logged out. Okay, so this is the place where we wanna inject our code now, because after creating a user with Firebase, we also need to authenticate with Stream, right? And to not pollute this too much, I've prepared a file called stream auth helpers, and we will put all the code that we need here. So the first thing we need to do is we need to get a token, right? And the cool thing is that we installed the extension. And what the extension did is, and I can show this in the console here. So what it did is it created a few cloud functions for us. We didn't have to write anything. These are created. They are using different triggers. So for example, we're creating a stream user whenever a new user in the Firebase auth is created. So that's nice. That's automatically run. We don't have to do anything there. And then it also has this nice get stream user token cloud function that is what we are using here, right? This is the name of it. And it makes it really easy to call this. We're just initializing it. And then, yeah, we're calling it. We don't even have to give any parameters to it because it's smart enough to know it's running in the stream in the Firebase context, so it's getting all the user information from that. And so we're creating a token and trying to create a stream token from that, because the token is just a string. We're creating the stream token from that and returning that. In case anything happens, we're just returning nil. So returning nil means, yeah, there can be errors, right? So we create an error enum. We can have two kinds of errors. So the cloud function might fail for some reason, or the user connection for stream might fail, right? And we just create an enum for that so we can cleanly implement this. And now we can do the actual login. And it's actually not that much code, right? So first thing we do is we are creating a token. We're using the function we just created. In case this fails, we are returning a failure. We're using the result type here. And then we're building up a user info dictionary for the stream backend to connect the user with the user info and the token. In case something fails, we are returning an error. Otherwise, we return success. With that, we should have all the code ready. So we can jump back into the auth view model and replace this code here with the call to the stream login. So we're using a task because we're using async await, and we are doing the stream login call with the data that we have. And then we're checking the result. When it's successful, we're still doing the login. And if not, we are just showing an error message, right? So let's run this. We can see this in the simulator here. It's running in a second. I can quickly jump here to say, yeah, so we only have one user, which is our test user with the very real email, of course. And also, we can jump to the Stream dashboard because we got the access keys for that. Now we can go to the Explorer, which is exploring the data that we have. And if we go to users, we also see we have this test user here and the admin user, okay, but we don't have anything else, right? So the app is launched, which is great. I want to create a new account. I want to sign up. I will use my company account for that because why not, right? I'll create a password and I'll sign up. It worked, right? So applause, right? It worked. But what did really happen there? Like, okay, it worked, it looks nice, but that was what was happening before as well, right? So yes and no. We were creating a new user here in Firebase, and we can refresh this to see, yep, this user was created, nice. And what we'll also see, the same user was also created in the Stream backend. So we can see here, that's me, right? That's me. So that worked, and that was the cloud function, which was doing all this, right? So it worked. We connected the two. We didn't write any server code for that. So yes, that's very good. I like where this is going. So we've implemented the token exchange. Check, right? So next is connecting the UI. So I already mentioned that Stream offers some built-in UI elements that we can reuse, basically. So let's do just that, right? We've implemented this, right? But what we want to do now is we want to create this chat button here. So we want to have some form to get in contact with the verified seller here. And so let's build this, right? So we can see this is the product details page. And I can jump to the, oops, I'm not printing this time. So we can jump to the product detail page. And we see we have the code here. It's having the product name, the description, the price. And below that, we now want to add a button that says contact. So let's do this. It's fairly simple, right? An HTAG and a navigation link, because we want to navigate to a new page. All right, so what we need to do here is we need to create a new chat group, chat channel, right, with the person logged in and the seller. So a good place to do this is maybe a view model, right? And luckily we have one prepared. What a coincidence. And we can fill this up, right? So we're already having the chat client here, and this is using a dependency injection mechanism that the Stream Chat SDK gives us. So anywhere we need the chat client, we can just inject it like this. And now we need to get a channel controller. A channel controller will be used to, well, control the channel. Makes sense, right? And the code is pretty straightforward. We're creating a channel ID from the product ID that we're receiving. We're getting the seller ID from the product. We need this because we want to add them to the chat. And then we're creating the channel controller here with the channel ID, okay, the product name as the name of the chat. And we'll create two members. So these will be the two people being part of this group and being part to chat. The current user should be a member, yes. We're catching errors, returning nil. We could do more for error handling, of course, but you know, we're a two-person team, so limited resources. And in the end, we call synchronize to make sure that everything works and the channel is actually created. Right, that looks good. Now we only need to call this, right? So here we have the navigation link. And now we need to call the get channel controller. We're getting the user ID, okay? And then we're getting the channel controller. Okay, we're calling the function, nice, that works. And what we're then doing is we're navigating to a chat channel view. Now this is one of those components that Stream offers. So we can basically drop that in and get chat for free, right? We only need to hand it a channel controller and a view factory. And you might see, it doesn't find it yet because we haven't created it yet. So let's do this because I wanted to mention that this is an important file if we want to work with Stream Chat. So let's create this. we need to import the Stream Chat SDK and the Swift UI one as well. And actually, let's also import Swift UI because we probably need this later. And now we can create this class. It's called myViewFactory. And it's of type viewFactory, right? And the only thing it needs to work is a chat client. So you can see, okay, it does not conform yet. So let's make it conform here. All right, it needs a chat client. And I've mentioned we can use the injection mechanism that we create, making this a chat client, and we get this injected. Cool. This works, right? But we need one more thing, so we need to initialize it with some props. So let's do this. We have the channel controller and the selected product. We will need that in a second, and I'll get to that. But yeah, that's it for now. So if we run this, let's see if it builds. It does. That's good. That's a relief. So we're waiting. We still have our products here, right? And now we have this new button here that says Contact. And if I click this, yeah, this opens up a new chat. So what I can do now is I can open up another simulator, and I've prepared this. So this is the seller logged in. And we can now see, we can also navigate here and do contact. Now let's try if this works, right? We want to chat. So let's do this. Hey, I'm interested in buying this. Okay. We should see this now. That's the beauty of live coding, right? So somehow it's not working yet. Let's reload this. There it is. All right. Maybe something went wrong. OK, but now we can say, yes, great, you can have it. We already see the typing indicator here. Nice. Awesome. I'm so happy now. Perfect, right? We've had a chat. Now you see, this is all using like pre-built components. We didn't do any custom UI there yet, but it's been working nicely. So so far, so good, right? We've added chat. Nice. Let's jump back to the presentation. We connected the UI. Great. And now we can say first feature done. Very nice. But there's still another one missing, right? So we also want to get email done. And this is where I will hand back to Peter to talk more about this.
I'm stepping out my Firebase here. So we want to implement sending emails as well. So, and here are the 3 steps, because all good things come in 3. We want to install a Firebase extension. We need to trigger sending the email, and you'll see that it says via Firestore, and I'll explain why in a minute. And then we need to trigger that, and for that you can see this little blue button in the left-hand corner. So when the user taps on that, we want to trigger sending the invoice or the receipt. So let me go back into the project, actually into this one. So first of all, I want to install an extension for sending emails. So let me go in and say, OK, I want to explore more extensions. And then let me search for email. And there are a few. And this one, trigger email, sounds like the one I might be interested in. So here it says, composes and sends an email based on the contents of a document written to a specified Cloud Firestore collection. And then you can see here, we've got a code sample. This obviously is not Swift, but some other language that we might not be privy to. But how it works is the following. I want to send an email to somebody, so I will create a new document in Firestore. A document is essentially like a record. and I add all the information that this extension needs to send the email. I add the address of the person that I want to send it to, I add the person I'm sending it from, the CC, the BCC, the title, and the body, and any attachments. So I write this into Firestore. This extension will listen to this collection in Firestore, and whenever there is a new document, it will pick up that document and generate an email using HTML body, and then send it via SMTP. Okay, so we'll install this. I'm going to pick this project here, and again, I'll have to walk through a little bit of explanation, and then down here, it will ask me to provide a lot of detail. And instead of boring you with finding all those details and plugging them in, we'll just jump over to our production project where we've prepared this already, and I'll just show you how this looks like. So you can see that we've got all the details filled in for sending, SMTP servers, and so on and so forth. And you can configure this. So I could go in and reconfigure this extension. All right, and with that, let's go to the next step, which is triggering sending the email via Firestore. And that's something that we can do in Swift.
Great. First of all, what could go wrong? Like attaching my private Gmail account to this, right? Nothing. All right, so we're trying to trigger an email send here. So let's first think about what do we need to do, right? We want to add this button here, first of all. And then we want to show the receipt here in the chat, and also send this via email, right? So it's a few more steps we need to take. But luckily, we can customize the chat experience now to suit our needs here. So let's first jump here, and we need to talk about a few things because we want to expand now. We don't want to only use the pre-built components that we get offered, but we want to customize them to use our own. All right, so we need to do a few things. We need to first say, all right, we do some custom messages, and in the stream world, this is called custom attachments. So we need to create a custom attachment payload. So this is for the receipt. We're creating we have a product here. We have the mail address. That's all we need really to send out the email. So that's good. And then we need to do something called message type resolving. What this is it basically saying to stream chat, please examine every message that you get and check, does it have a custom attachment? So does it have a receipt to it? If yes, then return true. Easy, right? And we're doing this, we're checking message attachments. If the count is larger than 0, fine. Let's do this. So we need to tell stream to use this custom message resolver, right? So we go back to the app delegate, and it's 2 lines of code actually. So let's code this out like this. So we're creating a new object here, which will be a custom message type resolver. Good. And then stream offers this utils object. And you can see by the autocomplete, there's quite a few things to customize here. Luckily, we only need one of this, which is the message type resolver. So we can hand this in. And then also tell stream chat, hey, we did some customization, so we also hand in the utils object here. Okay, so stream will now detect whether we have a custom attachment in a message. That's a good start. But now we also want to show this in some form, right? We're going to show some UI for that. And I've prepared the UI for that, so we can see this here in the view. So we have the button that you saw there, like the blue button at the bottom. And we have the attachment view. Like this is, we will jump into the button in a second, but the receipt attachment view is just, it's a Swift UI view. It's nothing spectacular, right? Just a bunch of code that gets one of these payloads handed in, right? Okay, so let's think about how can we add this button. If you look at this, we see it's added here, and now we want to have it here, right? The thing at the bottom here in the stream world is called the composer because you compose messages with it. And this is coincidentally called the leading composer. which is good, right? That's what we can use. And I told you that the view factory for Stream is the place where we can customize stuff. So let's do this, right? So we can create the leading composer here. And it's pretty easy, right? We do the make leading composer view. We override this instead of using the default one that we saw earlier. So this is the default one. We're customizing this. We're creating our own button here and adding that. So that's good. We can run this, and we will see the button is there. But the button, as of now, does not really do much, right? So that's a problem. So again, here's the chat. We have the button now. Cool, that's good. Good first step. But when the button is clicked, we want to send a message, and we want to send an email, and then also show it in the chat. And to show it, we can use another override here, because if we want to show a custom attachment, we can use the make custom attachment view type. And then for each of the receipt attachments, we just put them in a VStack, and for each of them, we just render it, right? I've showed you this code for this UI view, or for this view. It's fine, right? That works. But still, when we go to the button, it has a few states. So it's ready, processing, send an error. But what we're doing here when we click that is not really great yet, right? So we're getting the user ID, that's good. We're getting the email, that's also good. But we're printing it. I mean, yeah, you know how debugging works, right? That's it. But of course, we want to add functionality to this. So let's jump to a file I've created, the mail service. And we will actually create a new function here. So we add a function send receipt. And this is where we will trigger the email send that, of the extension that was just installed. So how this works, Peter mentioned this. So we're initializing Firestore here. We're going to the mail collection, and we're adding a document. This document consists of a few things. We have the message that has a subject, which is the email subject, some text, and the HTML we want to show for the email, right? And then we're sending this to a certain email address. So that's straightforward, right? If this works, we're returning true, otherwise false. Cool. So the only thing that remains for us to do is call this, right? And this looks like a lot of code, but we're actually just doing two things here. So first, we are calling this function we just created. So we want to send this receipt. If that works, so if that returns true, we are creating a new message here with the text and the attachment of our custom attachment. So we're creating this receipt attachment payload here. Right? If that worked, we're setting the button state to send. Otherwise, we're just printing an error. All right, let's run this. And wait for a second to build. So we can leave this open. We now have this button here ready. We can click on it. It loads. It shows that it apparently worked, right? So let's check email, because we might, oh, look at that. We just received an email saying, hey, this is the receipt for this product. We bought the M1 MacBook Air for the price of $1,200. Not sure if that's good, but well, we trust the source, right? He's verified. So yeah, basically that worked, right? So nice. We sent an email. We added the custom attachment. That's check mark and check mark. So very nice. For both features, we say, yep, we added those. Very good, right? I'll hand over to Peter to talk a little bit more about that.
Okay, so now you're wondering what kind of other extensions are there. And to find out, you can go to extensions.dev, which will give you this nice looking landing page with a couple of extensions that you can browse through. There are more down here, and you can click on view all extensions to see all of them. But now I know a lot of you might be asking, so Peter, can I build my own extension? And yeah, one more thing. you can actually do that. So you need to sign up to our alpha group, which gives you early access, and then you can build your extension and publish it on GitHub, and then people can start using it. So again, 3 steps, because all 3 things come in, well, all good things come in threes. So you need to install the Firebase tools, which is a CLI tool that you also need to manage your Firebase project. Then you write your Cloud Functions, and that's when you actually need to learn JavaScript or TypeScript. I guess we'll have to buckle up, Stefan. But show of hands, who would like to have their Cloud Functions understand Swift? Who would like to use Swift to write Cloud Functions? All right, yeah, so that's quite a few of you. All right, great. So I'll take a note of that. And then you'll package your extension. And the way how it works is you have this YAML file which says, hey, this is the name of the extension, this is where we get it from, this is what it does. Here are all the parameters that you can configure. And by the way, this is the very YAML file that's from the extension that we just used. So real stuff here. And then if you want to implement functionality, you'll either have to write JavaScript or TypeScript. And again, this is from the stream extension here. And we can see the function that creates the user. So it's pretty straightforward because, actually, most extensions will be glue code sitting between a third-party service and Firebase, unless you want to build like a full backend solution in extensions. That's possible too. All right, let's wrap up.
Sounds good. So just quickly, so what have we done? We have built the 2 new features that we wanted, right? So we can do check marks on that. Great. This is what our tech stack looked like before. And remember, like we had these limitations. We're just 2 small, innocent developers with limited abilities. And like the tech stack after that, well, it's not that complicated, right? Nothing too much changed here. We have the extensions. Yes, we added that. We didn't write any server code for that. We added chat, no server code as well, and the UI for that. So that's pretty nice. I think we've achieved the goal that we wanted. We didn't have to write any custom code here for the backend. We could stay in our cozy place that is Swift, which is great. So yeah, that's all from us. If you have questions or if you're looking to fund us maybe, then come talk to us. We're also hanging out here, so feel free to contact us, talk to us, and otherwise, thanks for the attention.
Anybody have any questions? Oh, wow. I'm going to need some help there. Okay, let's do this in like 2 or 3 bounces. So Johan, you first. And you get it further back. Maybe to Ben. And then, yeah.
Ooh.
Oh,
Perfect.
good throw.
Thank you. My question is, what does the review process look like for the extensions? Because some of them look to have a little like a blue check mark for some of them, and some
you
didn't.
think they're verified? The verification process is you will publish it on your GitHub profile. So you basically are responsible for doing good and not doing anything illegal. And people who want to install it into their application have the responsibility to have a look at your code and see if it does what they expect. And then when they install it, what happens is that actually your code gets cloned into their Firebase project. So if you were to change your code in GitHub and implement something maliciously, it would not have an impact on their project. So that's the safeguard at the moment. It's very different from, for example, Google Assistant, where you would ship an application to the Google Assistant store and people would run it on their devices and would have no insight into what's happening. So here the developers actually can see what's happening.
Anybody else have a question? Try and get the cube over there without hurting anybody.
Hello. So you said you don't have a lot of resources. How much would this cost you using both of the Stream SDK and the Firebase functions?
Great question. Great question. So, like from a stream side, I can only say we have different plans. So we have a maker plan, which means I think like teams below 5 people and under like 10K monthly revenue, something in that realm, are free. Right?
With that plan, with the maker account, we always say if you run into the limits of that, then you'll gladly pay us because then the business value is already there and you should be having an income already.
So yeah, like that's the stream part. The extensions part, like you don't pay for extensions per se, right? So that's not like a paid product, but Firebase.
Yeah, so for Firebase, we've got 2 plans, and I've called up the Firebase pricing calculator. So there is the no-cost plan, which is called the Spark plan. Everything's free. Everything is at no cost. And then there is the pay-as-you-go. And to run functions, you need to use the pay-as-you-go because you're actually using compute power. And then you can use this Blaze plan calculator to figure out like how much it will cost you. And then you'll have to put in the data that you think is relevant for your project. How many Firestore documents will you create? How many do you think people will read? How many function invocations will you have? And then it will basically give you a number. And it has very, very generous free limits. So everything that you can see here is basically the limits that you get at no cost. So if you store like 1 gigabyte of data in Cloud Firestore, it's at no cost.
Thanks.
And that's, by the way, that's one of the places I always tell people to go if they ask, oh, so if I use Cloud Firestore to store my data, can I use cloud, what's it called? Not cloud storage. Core data. Can I use core data as a local cache to store my data from Firestore into core data? Well, of course you can, but you're hurting yourself. And the reason why, whenever I ask, why would you do that? They're like, oh yeah, to save cost. And I'm like, okay, have you actually put the data in here? Have you done the math? Do you know how many users you have, how many documents will you have, and do the math. And it's surprisingly cheap. Like even if you have millions of documents, it's just a couple of dollars that you'll pay per month.
More questions?
There's one at the front.
Hello. Hey, it works.
Hello.
Great presentation, by the way. So I'm curious on the stream side. You mentioned you have a chat channel, and you're adding I don't know the terminology, but I'll go with the participants to the chat channel, both on the seller and the buyer. But I'm curious, a couple of things. Does that chat channel has an identifier, and then can you add the participants at a later point in time? What happens once you end the chat? Do you tore down? I'll go on a limb and say it's probably a WebSocket somewhere. Do you tore it down, or do you keep it alive? And then you can inject the buyer again into the chat and have some sort of a long-lived / persistent messaging.
Good question. So the answer to that is yes. Basically, we can have a look, right? So if you have a look here, like at the channels, we created this, right? This is the channel we created. And you see, like there's the members, there's the messages there. So yes, you can add people to it. Afterwards, you can set if they should see the messages or not that were sent previously, right? So you can have different access rights. It's using WebSockets under the hood, right? It needs to have some form of constant connection and get the new messages that are coming in. But yeah, you can do a lot of things with it. And everything you mentioned, like adding users, deleting them from the chat, adding them again, you can do all of this. And yeah, like there's functions or like there's functionality for all of this.
Wonderful, thank you.
Cool, nice. I think there was one more question at the front
there,
right?
Hey, so I'm not going to lie, as soon as you both presented yourselves as developer advocates, a large amount of skepticism formed within me because, I recognize that it's going to be more of a sales pitch than a kind of analysis about the products themselves. So with that in mind, I just wonder, to appease my skepticism, how does this actually compare to a lot of these new Y Combinator startup codeless backends or even open source projects that try to provide similar services? What are some of the cons that you have? Maybe even some of the things on the roadmap that you're trying to do to match the other competition? Yeah, I'm just wondering what's the dark side of this.
Are we
Who's this for? Is this for both of us or?
Both, honestly.
Yeah. Should I go first? I can go first.
Yeah, go first.
Okay, so stream-wise, I mean, I don't really know if there's a dark side to it. I mean, you have to pay for it at some point if it's scaling, right? So that's the pitch there, right? So at some point, server capacity will go up. We will manage this for you, but this requires some costs, right? Of course, there's new products coming out. I think some of them are really great, right? I think the cool thing about Stream that I'm probably a little bit biased maybe, but I think the cool thing is that you get everything managed, so you don't have to take care of custom servers because that can be tricky at times, right? I don't know if you've ever worked with Kubernetes, but yeah, it's a different beast. So I think this is the pitch at least that Stream gives, right? You can start for free. And if that works for you, then we have different plans that will also scale up very, very nicely. And for Firebase?
Yeah, so I would completely agree with Stefan, what you said about servers. So a lot of people say, I've seen a couple of tweets or conversations on Twitter where people said, use Firebase, it's great to get started, and once things get serious, you can always run your own backend. I'm like, oh my God, why would you do that? I mean, let's talk about authentication. If you're thinking about running your own authentication system, I would strongly encourage you to think twice. And that's why I say on stage, come talk to me afterwards and I'll find stronger words. We have a large team that works 24/7 around the clock, around the world to make sure that this is not hacked and this is secure, that your data is kept secure, that we implement all the security patches and all of that, that we keep up with what the industry is doing and implement new ways to authenticate. So that's just one thing. The same goes for servers. We will make sure that you have very, very little downtime, that everything is stable and all of that. In terms of, is it just for hobbyists or not? We've got large customers. I can't name them, but you can look them up. So it's not for toy projects. And if you ever realize, well, the things that Firebase gives me are not enough, I need more, every Firebase project is a Google Cloud project. So you can tap into everything that Google Cloud gives you and use it seamlessly, right? So that's another advantage. Obviously, the other competitors are doing great stuff as well, right? So I'm not here to diss them. They're doing great stuff. It's your responsibility to take a look what you need and what's the best for you. And let me close with one little story. So there is one developer who built a tool to schedule tweets. And his story is, he built this tool where you can write down the tweets and schedule them, and he built it as kind of a hobby project and put it out there. It runs on Firebase, it runs on the Spark plan, so it didn't cost him anything. And he told a couple of friends about it, they used it, but there was no big uptake. And then one very, very well-known Twitter user started to use it 2 years after he launched the project. 2 years, and he didn't pay anything for it. So that person started using it, and he saw a lot of traction out of a sudden. And then he was like, oh wow, this is now becoming a business. So he put a pricing plan in front of it, and now it's supporting a small company, not a large one, but a couple of people. And he told us, I was only able to do that because I started on the free plan, and then it scaled up, and I only pay for what I use. So that's the positive story on which I want to close this answer.
Cool. Thank you.
Welcome.
Thanks for the question. Now we could do our marketing blurb as well. That's good.
That's the dark side. So thank you very much for your talk, and let's eat.